I will discuss improving the depiction of the medial medullary lamina structure on quantitative susceptibility maps. I have nothing to declare. The medial medullary lamina is critical in deep brain stimulation planning because it separates the globus pallidus anterior from the globus pallidus exterior, where the former is targeted in deep brain stimulation surgery. An overview of reconstructing the QSM from multi-echo gradient echo phase data is shown. Although the QSM is derived from the phase data, the magnitude image is used to regularize the cost function that reconstructs the best map from corrupted data. Conventionally, the magnitude image is used to generate a mask M that will be discussed in later slides. Here, we propose using the tissue field from the unwrapped phase data for the mask M instead in the regularization term. The cost function to minimize is shown above, with F representing the data fidelity term and R representing the L2 regularization term. The focus of this talk is the L1 term, containing the mask M that I mentioned. The magnitude image on the left is the conventional choice to construct the morphological mask M, which specifies the voxels containing edges in the final susceptibility map. But the local field image on the right can also be used, as is proposed here. The mask term M is obtained by binarizing the gradient of the magnitude image. Similarly, we can binarize the gradient of the local field, which reveals more detail in the globus pallidus region. The black voxels are zero-valued and not penalized by the cost function, so they represent regions where edges are permitted in the final susceptibility map. Notice more voxels are permitted to contain edge information in the proposed phase prior mask than in the conventional magnitude prior mask. Two QSMs were reconstructed for 10 patients, one map using the conventional magnitude prior and another map using the proposed phase prior. Each QSM is submitted for radiological scoring, segmented, and the contrast to noise ratio, or CNR, is calculated with a region in the thalamus used as the reference standard deviation. Here is an example of QSM showing the improvements in MML visualization when the phase prior is used. Notice the boundary of the MML is more clearly delineated in the phase prior image. This QSM received higher radiological scoring. In fact, the reader selected the phase prior as the superior QSM in all 10 cases. The CNR was also significantly higher on the phase prior QSMs at all the boundaries of the MML. In conclusion, the phase prior can improve visualization of certain structures, such as the medial medullary lamina, on quantitative susceptibility maps.